investigating science and technology.
Good day everyone, I am teacher Rhea and I will be your science teacher for the whole school year. Welcome to the first quarter of our Science 7 class. Our topic for today is all about scientific ways of acquiring knowledge and solving problems scientifically, or simply the scientific method and its steps. At the end of the topic, you are expected to define scientific method, describe the steps of scientific investigation, and lastly, be able to solve problems using the steps of scientific method.
Summary of the topics. Unit 2. Scientific ways of acquiring knowledge and solving problems. 2.0 Scientific method involves a series of steps that are used to investigate a national occurrence. 2.1 Scientific investigation. What is scientific method? What are the steps of the scientific method? Key terms: observation, experiment, hypothesis, conclusions. General objectives. What you will learn. In this chapter you will define scientific method, skills you will use. In this chapter you will describe the steps of scientific investigation, and be able to solve problems using the steps of the scientific method. What is scientific investigation? Scientific investigation is the way in which scientists and researchers use a systematic process to answer questions about the world around us. It is a way of finding the answer to a question using the carefully arranged steps. In other words, the scientific method is a systematic process that involves measurable observations to formulate, test or modify and prove a hypothesis.
Why are some kids sad? What makes the wind blow? How do birds fly? Our world is full of curious phenomena. To find answers or solve problems, we can use a process which was first acknowledged by the scientist and philosopher Ibn al-Haytham in the 11th century. Also known as Alhazen, he is considered to be the father of optics and the scientific method. There are 6 steps to it. 1. Observe and ask questions. 2. Research. 3. Formulate a hypothesis. 4. Test your hypothesis. 5. Conclude. 6. Share results. The goal of the scientific method is to find out the truth. Let's try. Step 1. Observe and question. Observation helps us formulate challenging questions that you will be able to test. A good question converts the natural sense of wonder into a focused line of investigation. When is the best time to drive to school? Which food is my dog's favorite? For example, if you observe that women smile more often than men, you might ask, why do women smile more often? Step 2. Research. Find out if other people have asked the same or similar questions. If you research online, use search terms like study, research, or meta-analysis, which is a summary of research for a specific topic. Read as much as you can about your particular subject to see what you can find out about. For example, research happiness based on gender or study the science of smiling in different cultural contexts. Step 3. Formulate a hypothesis. A hypothesis is a theory that you can test to see if your prediction is right or wrong. From your observation, you have noticed that women smile more often and that people who are smiling seem to be happy. From your research, you know that there are different types of smiles: shy, genuine, and false. In one paper, you read that baby girls smile more often than baby boys. Here is a hypothesis. Women smile more than men because they are happier than men. Step 4. Test your hypothesis. When you test your hypothesis, you want to make sure to do this in a fair way and that the conditions are constant. For this hypothesis, we can design a test where an interviewer talks with a set of men and women for 5 minutes each, counts how many times they smile, and then asks each one to rate their level of happiness. To get a good sample of the population, we invite 300 women and 300 men. Seems like a good test, right? But wait, What if the interviewer is a woman and men tend to smile more at women? Or vice versa? Or what if the topic discussed is one that interests women more than men? And what if people aren't reliable reporters of their actual level of happiness? So clearly, we would need to be much more careful. Step 5. Analyze and conclude. Let's assume that you designed a very careful experiment, controlling for as many variables as possible. Now you can analyze the data to see if your hypothesis is correct or incorrect. Depending on your findings, you may want to change your hypothesis or change the design of your testing. Perhaps you have discovered an even more interesting question. This stage of the scientific method can be repeated as many times as necessary until you find just the right hypothesis and test method to find accurate results. Step 6. Share the results. When you are satisfied that you have proven or disproven something important, report your results. In science, it is important to detail your methods so that your peers can review your work, which is a critical step to getting published. If your results are solid, your experiment can be repeated by other scientists. Such reproducibility is a sign of good scientific work. But failed results can also be interesting. An incorrect prediction could prove to be important and should always be reported. To make sure you get it completely right, here are 3 more things you can check before you publish. A. Any scientific theory is falsifiable. Real scientists know that there is no such thing as a scientific proof. In other words, you can never prove your theory to be 100% right. All you can do is find a lot of supporting evidence that it could be correct. Here is one example. Say that someone says, hamsters can fly. We cannot prove that this is false. Yes, we have never seen a hamster fly, but we can't test all possible conditions or look in all possible places on the planet to know that all hamsters never fly. Maybe a space hamster does. So while we can often prove that a phenomenon exists, it's much harder to prove the non-existence of something. If your theory can't possibly be proven wrong, then it's not falsifiable and hence not scientific. B. Correlation is not causation. When you analyze your results, it is important to separate between 2 possible reasons: correlation or causation. Let's say you hear that towns that have more churches also have more bars. Could it be that religion makes people want to drink, or that drinking helps people to find God? If you add more facts, such as larger towns have both more bars and more churches, you can see that a larger population is a more likely cause of higher numbers of bars and churches. There is probably a correlation, but no causation. If we compare men with women and would conclude that women smile more and are more happy, then this still doesn't mean that it's happiness that makes them smile. Maybe they just eat more chocolate and cookies, which makes them both happy and smile a lot. C. Avoid selective windowing. When you publish, you've got to show all relevant facts. Colgate once ran an advertising campaign claiming that 80% of dentists recommend Colgate. What they didn't tell us is that when they asked dentists to select their preferred toothpaste, Colgate was just one of many other brands they also recommended. Colgate was later sued and forced to take down their misleading ads. The purpose of science is always to find out the truth and nothing but the truth. To use science to mislead us is wrong and terrible business practice. Let's do a last example together. I have 2 coins. One is bigger. Why? The small coin says 1 cent, the bigger one says 5. Aha! Small coins are worth less money. Bigger coins are worth more money. I pull some more coins from my pocket. 2 more pennies, 1 more nickel, and $0.25, which is 25 cents. Great! My hypothesis seems true. But wait, is the quarter worth more because it is bigger? So is that a correlation or a causation? My sample size is pretty small, I don't think I am ready to report my results. Can you help out? Please apply the scientific method to study your local currency. Maybe you have a hypothesis that we can test until we get solid, repeatable results to report. Please publish your findings in the comments below.
Have you ever thought about what goes into a real scientific experiment? Most of us get to do science investigations when we're young. School experiments are easy and fun. But what about real scientists like chemists, physicists, and medical researchers? What kind of work did they have to do? How do they go about designing their experiments in the laboratory? Experiments, remember, are one of the key components of the scientific method, which is a set of procedures that scientists follow to gain knowledge about the world. Other components of the scientific method are questions, hypotheses, observations, analyses, and conclusions. While experiments are only one part of a scientific investigation, they end up being accountable to the other elements. In this lesson, we'll see what goes into making a valuable experiment and learn how scientists design useful investigations. A scientific experiment is an ordered investigation that attempts to prove or disprove a hypothesis. So its primary purpose is to test whether someone's prediction is correct. In designing experiments, scientists have to answer some pretty complicated questions, like, does my experiment answer the question I'm trying to solve? Does it adequately test my hypothesis? Can I make observations about the results of my experiment, and will I be able to analyze those results? Finally, if I run this test, will it allow me to come up with some kind of conclusion? Scientific experiments are different from other kinds of tests because they are required to fit in with the scientific method. Another important factor is peer review by the science community. A scientist's work isn't generally recognized unless he follows the standards set by other scientists around the world. A few basic rules apply to the design of a good experiment. Let's take a look at what a science experiment needs. Rule number 1. The experiment must show that a hypothesis is either supported or not supported. In science, we try to avoid using terms like right and wrong, and we don't say that hypotheses are proven or disproven until we're really sure about it. A single experiment is not enough to prove anything with 100% certainty. The second rule is that the results of an experiment must be measurable and objective. Scientists use standard units to measure different properties like length, time, volume, mass, and speed. Sometimes we need special equipment to observe things in a measurable way. For example, we can't see ultraviolet light or hear infrasonic sounds. We need special devices to detect and measure those properties for us. The third rule for scientific investigations is that the experiment must be repeatable by other scientists. Peer reviewers want to make sure that other scientists can run the same experiment and get similar results. This is one of the reasons we standardize our measuring tools and equipment. Scientists must be able to read anyone else's report, follow the steps exactly the same way, and compare their findings to the original test. In science, new ideas aren't taken seriously until many scientists have tested them many times. So it's important that scientists share their techniques and confirm each other's findings. So, how do scientific ideas become part of the community knowledge base? If everyone's always double-checking each other's work, how do hypotheses become theories? How do theories become scientific law? Well, first of all, keep in mind that theory in the world of science is not the same thing as a theory in everyday language. I might have a theory that my friend Jackie is going to ask her classmate Jimmy on a date, but that's not the same as a scientific theory. In science, a theory is a statement that is generally accepted as a summary for a hypothesis or a group of hypotheses. You can also call a theory an accepted hypothesis. When one hypothesis has been tested by many different scientists, and most of them have come to the same basic conclusion, then we can start calling the hypothesis a theory. There isn't any grand master of science who makes the final decree about a theory. It's more like a general consensus. And a theory can still be disproven if further research reveals enough evidence to refute it. A law is different from a theory in that it is viewed as a universal fact. A scientific law is a general statement about a group of observations which has no exceptions to the rule. Most laws can be stated as mathematical equations, like Boyle's law and Pascal's law. Laws in biology are statements about how living things.
In this video, you will learn the difference between independent and the dependent variables. In a science experiment, you have three variables: the constant variables, the independent variables, and the dependent variables. The constant variables are variables that don't change. In this video, we will focus on the difference between the independent and dependent variable. An independent variable, which is also sometimes called the manipulated variable, has the ability to stand alone. It is the variable you are changing or manipulating. In simple terms, you change the independent variable. The dependent variable, which is also called the responding variable, depends on the independent variable. It is the variable you are measuring. In simple terms, the dependent variable is what you measure. Let's look at some examples and see if we can understand the difference between independent and dependent variable a little bit better. It is summertime. You would like to know if the color of the car impacts the inside temperature of the car. You find 4 cars of different colors and park them outside, and you measure the inside temperature of each car every 30 minutes for 2 hours. The color of the car is the independent variable because you have 4 different colors and you change this. Remember, the independent variable is what you change in the experiment. The temperature inside each car is your dependent variable. It may vary according to the car's color. You will be measuring this variable by taking the temperature inside the car every 30 minutes. Remember, the dependent variable is what you are measuring. Let's look at a couple more examples. The height of a tree depends on the amount of water it receives. The amount of water the tree receives is the independent variable. The amount of water that the tree receives will change, and the height of the tree is the dependent variable because you are measuring the height of each tree. Another example, will eating 5 servings of bananas a week reduce the blood pressure in male patients? The number of bananas that the patients eat each week will be the independent variable because it will change, and the blood pressure is the dependent variable because it is what you are measuring. When graphing the independent and dependent variables, you can remember which axis they go on by using the term dry mix. The D stands for the dependent variable, the R stands for the responding variable, and the Y stands for the y-axis. So that means the dependent variable is graphed on the y-axis. Mix stands for M is mix, manipulating, the I stands for independent, and X stands for the x-axis. So therefore, the independent variable goes on the x-axis. It's just an easy way to remember which axis they both go on. So I hope this helps you in understanding the difference between an independent and dependent variable.
Components of a scientific investigation. Scientists are by nature keen observers, that is why they can easily perceive areas where problems exist. Having identified the problem, scientist undertakes a carefully planned investigation following a systematic and logical approach using steps in scientific method. Components of a scientific investigation. 1. Statement of the research problem. Choosing a problem to be explored also requires preliminary steps to ensure a successful investigation. First and foremost, you should have an existing knowledge on the problem. To reinforce that existing knowledge, conduct research by collecting information from print and multimedia, interviews, and observations in the environment. This part answers the following question: what do you want to know? Example: how does fertilizer affect the growth of the plants? 2. Formulation of hypothesis. Once the problem is identified and a testable question has been proposed, you can now formulate the hypothesis. A hypothesis is a simple statement that presents the possible solution to the problem. It can be tested, and is based on knowledge and research. A hypothesis can be an overall statement about the observation or a guess about what caused the pattern in the observation. Example of hypothesis: fertilizers have an effect on the growth of plants. Plants with fertilizers will grow bigger. Hypothesis can be stated in 2 ways. A. Null hypothesis or HO. Hypothesis that states no relationship between variables. Example: the fertilizer does not affect the growth of plants. B. Alternative hypothesis or HA. Hypothesis that states a relationship between variables. Example: there is significant relationship between the growth of plants and the use of fertilizer. 3. Testing hypothesis and gathering data. At this point, you are ready to test your hypothesis by conducting an experiment. An experiment is a set of manipulations or specific observations of nature, and it is considered the most important part of scientific method. It is done to answer the research questions or investigate a problem. There are 3 types of experiments: controlled, natural, and field experiments. Controlled experiment generally compares the results obtained from an experimental sample against the control sample. Under this type, the observer tests the hypothesis by looking for changes brought about by alteration to a variable. Natural experiments or quasi-experiments are those that rely solely on observations of variables of the system under study. Here, the observer does not manipulate any variable, but simply collects all the possible data to determine the factors affecting a particular phenomenon. Field experiments, the third type, is named to draw a contrast with laboratory experiments. It examines the real world using scientific method, and it is often used in social sciences such as political sciences, economics and psychology. A variable is a characteristic, number, or quantity that increases or decreases over time, or takes different values in different situations. It is anything that you can change or control in an experiment. There are 3 kinds of variables in an experiment: controlled, independent and dependent variables. A. Controlled variables are variables that are kept constant. They do not receive any treatment. In the previous example, the controlled variables are the amount of water and sunlight received by plants, the temperature, the amount and type of soil, and the size of the pot where the tomato seeds have been planted. B. Independent variables are the factors that you change or alter during the experiment. These variables cause a corresponding effect in other variables. The amount or the presence of fertilizer is considered the independent variable in the sample experiment. C. Dependent variables are the variables that you observe, and they are considered the response to an independent variable. They include the growth of plants in terms of height, number of leaves, and other characteristics. 4. Analyzing and presenting data. Data obtained from experiments should be analyzed and presented systematically. The data may be presented using a table for easy interpretation. 5. Creating conclusions. The 5th step of the scientific method is drawing a conclusion. A conclusion is a summary of the results of the experiment, and the statement of how the results match up to the hypothesis. There are 2 options for a conclusion. One is to reject the hypothesis, and the other one is to accept it. If a good conclusion has been tested often enough, and showed valid and reliable results each time, it then becomes a theory, a scientifically accepted fact. A theory that has been tested and confirmed by various experiments becomes a scientific law, a statement or principle that is universally accepted. 6. Reporting of findings. Once the data have been obtained and analyzed, and the conclusion has been drawn, the next step is to share the results. This stage is important in perpetuating the body of knowledge gained and conducting the scientific method.
To summarize our topic for today, scientific method is an orderly process that helps man find possible answers to specific problems. In scientific method, we refer to the use of our senses together with the utilization of available technology. The basic steps of scientific investigations are: first, statement of the problem; second, formulation of hypothesis; third, testing hypothesis and gathering data; fourth, analyzing and presenting data; fifth, creating conclusions; and lastly, reporting of findings.
Activities. Activity 1, give me the problem. Given the following scenarios, give at least 3 or more problems in each scenario. 1. Your car won't start. 2. You received a failing grade in your test. 3. You have a sore throat. 4. Your plants did not grow. Activity 2. Directions. Identify whether the following situations are identifying problem or making observation. Write IP if the situation given identifies problem, and MO if the situation given is an observation. 1. Dana wanted to find out how grown plants with fertilizer are different from natural grown plants. 2. Teachers like when their students participate in classroom discussions. 3. Girls wearing Sunday dresses look beautiful and cool. 4. Jose saw bats catching insects after dark. He asked why bats can see in the dark. 5. People who live in the farm like dogs. For items 6 to 15, read each question carefully. Choose the letter of your answer. 6. Your mother sent you to the market to buy fruits and vegetables. How did you choose the quality of fruits and vegetables? A. Asked the vendor to choose it for you. B. Just took any kind and paid right away. C. Examined the skin of fruit free of insect bites and dark spots. D. Asked other customer to choose the vegetables and fruits for you. 7. A step in scientific method that may begin with what, when, who, which, why, where or how? A. Gathering data. B. Identifying problem. C. Forming hypothesis. D. Making observations. 8. It is any information that is gathered using the senses. A. Data. B. Situation. C. Observation. D. Communicate. 9. What is the first step in scientific method? A. Gathering data. B. Identifying problem. C. Forming hypothesis. D. Making observations. 10. Where does scientific knowledge comes from? A. Textbooks. B. Observation. C. Experimentation. D. Guess. 11. What step in scientific method is used when a researcher listens to the sounds of the whale? A. Interpreting data. B. Drawing conclusions. C. Making observations. D. Making a hypothesis. 12. Which question has measurable observation? A. Who made the first microscope? B. How many giraffes live in Africa? C. How long ago did dinosaurs live on the Earth? D. Does the amount of salt in water affect the temperature at which it boils? 13. How do you call the process of obtaining information by using the senses? A. Inquiry. B. Conclusion. C. Observation. D. Scientific method. 14. A series of steps designed to help you solve problems and answer questions. A. Hypothesis. B. Experiment. C. Observation. D. Scientific method. 15. Which of the following statements would be true of the scientific method? A. People structure their lives on the principle of scientific method. B. Scientists report the experimental results, but not the experimental design. C. The scientific method is a continuous process by which people learn about his world. D. When the results of the experiment do not fit the hypothesis, a scientist may discard the results and stop the experiment. Activity 3. Fill in the blanks. Directions: fill in the blanks with the correct word. Blank uses their frame of mind on curiosity. They do not usually accept an explanation without evidence or proof. To prove their point, they usually consider steps in doing investigation. The first step in scientific method is blank, wherein it must begin with a question that is based on an observation, and may begin with what, when, who, which, why, where or how? It should also be a blank question that can be answered through an experiment. On the other hand, blank is the second step in scientific method. A blank is any information that is gathered with the senses. In this step, the scientist will find out the blank, and make observations regarding the problem. Observations can be qualitative or quantitative. Blank describes properties or occurrences in ways that do not use measurement, while blank are based on measured quantities, number and unit. Activity 4, check this out. Directions: make an interview of at least 3 to 5 family members within your household. Based from the data you gathered, answer the questions that follow. Guide questions. 1. What is the most common sickness experienced in your family? 2. At what particular age bracket of the family members mostly are affected by the illness? 3. State the major health problem experienced by any of your family members. 4. Make observations on your sick family member and find out the possible causes. Performance task. Task 1, experiment, which will make the candy dissolve the fastest. Hot water, cold water, vinegar or oil. Hypothesis. I think blank will dissolve the blank the fastest. Guide questions. 1. What was the fastest? 2. Were you right? Task 2. In our current situation, identify one problem or question that can be addressed using the scientific method. Briefly outline how you plan to solve the problem using scientific method.
I hope you all learned a lot from our topic for today, and see you on our next science class.